Hello students, hope you all are fine. In the last class, we have discussed some 6 special formula. Here I have written all that 6 formulas. Integration of dx upon x square minus a square is equals to 1 by 2a log of x minus a by x plus a plus c. Number 2, integration of dx upon a square minus x square, and that is equal to 1 by 2a log of a plus x upon a minus x plus c. Number 3, integration of dx upon x square plus a square is equals to 1 by a tan inverse x plus c. Number 4, integration of under root x square minus a square, and that give us log of x plus under root of x square minus a square plus c. Number 5, integration of dx upon under root of a square minus x square, and that give us x sin inverse x by a plus c. And finally, number 6, that integration of dx upon x square plus a square is equals to log of x plus under root of x square plus a square plus c. So, these are the 6 standard form that we have discussed in the last 2 classes. Today, by using these forms or formula, we can solve some problems. So, now look at this problem. I equal to integration of root under 1 minus x upon 1 plus x dx. So, what to do? Integration of, I can rationalize it, and after rationalizing, what we can get 1 minus x upon 1 plus x into 1 minus of x upon 1 minus of x dx. So, this is integration of 1 minus x, that is root under, that is 1 minus x upon 1 minus x square and dx. Now, I have applied 1 minus x into 1 minus x, that is 1 minus x the whole square, due to this root, that is 1 minus x only, and a plus b into a minus b, that means a square minus b square. Now, look here, I can separate it two different integrals as 1 upon 1 minus x square dx I can keep here, minus integral of x upon 1 minus x square and dx. So, I made two separate integrals. Let us take this as one I1 minus I2. Now, I separately find the integrals of this I1 and I2. Let us check. I1 is equals to, that is dx upon under root dx upon 1 minus x square, and that can be written as integral of dx upon 1 square minus x square. Now, look at these formulas. It is nothing exactly looking what? Exactly looking like, it is exactly looking like our this number. So, dear students, I have taken here, I left this root sign. Okay. So, now look here. Now, it is exactly looking like number 5. So, number 5 means I can apply this formula, and that is what? That is sin inverse x by a. Sin inverse x by a means what? Here is your x upon 1, that is no need to write this one, you can simply put C1. So, that is the integration of I1. Now, I take the integration of I2. I2 is our x upon 1 minus x square. Here I write this I2 here. So, I write I2 here. I2 is equals to integration of x upon under root of 1 minus x square. Here I also left this root side. Now, x upon, now I can putting putting t equal to 1 minus x square, and that dt will give us minus of 2x dx, and from here I can shift this minus 2 to the left side, that will give us minus 1 upon 2 dt is equals to x of dx. Now this I2 become this I2, we can replace this I2 by this one, therefore our I2 become, here is dx, so x dx can we replace by, that is minus 1 by 2 up dt under root of 1 up by t, under root of t, because t equal to 1 minus x square. Now here that is implies 1 by 2, and we know that the standard form, that is 1 upon root t, integration of 1 upon root t is what, 2 times of root t plus c2, and that is equal to minus 1 by 2, the minus 1 by 2 and this 2 to cancel, that is root t plus c, and root t is what we have assumed as t is 1 minus x square. So under root of 1 minus x square plus c2, you can put c2 here. So now we are at the stage to give the final answer of this question. So that means our I1 is this one, I1 is this part is our I1, and I2 is our, this part is the I2. So our I was I equal to I1 minus I2. Okay, here also we put one minus sign, here is minus, okay, that means I1 is sine inverse of x, and this minus and minus of minus, this is plus, and that is root under 1 minus x square and 1 minus x square, and this C1 and C2 we combinedly we can write as C. So this is the I, this is our final answer, this I is the final answer. So this way we can find the solutions of some integrals by using these forms, all these forms. I show you one more. Let's take one more question. Now look at this question. We have I equal to integration of dx upon a square sin square x plus b square cos square x. First we have to simplify it, and we want to bring in some form of like this, like out of these 6 forms. So what to do? I have to multiply and divide by cos square x in the denominator. Let us see, that is equal to integration, I keep this dx as dx a square sin square x plus b square cos square x as it is. I keep all this in a bracket, and now I multiply some cos square x here and divide the cos square x here also. This cos square x we can take in the numerator. So when we take it in the numerator, we will get sec square x, and dx will be here with this. I can divide these terms and this term by this cos square x, and that will become sin square x by cos square x, means tan square x. You have a square here, that is tan square x, okay, fine, and this b square by cos square x, that is simply we have b square. Now we have changed this integration as this in this form. Now if you assume this is as t, this is a let t equal to tan x, then dt equal to sec square x dx. Now check, this sec square x dx means dt and t is tan x. So that means our integration I is equals to sec square x dx can be written as dt upon this is a square, okay, fine, and this tan square is t square and plus this b square. Now I change the variable in t. Now we can take out this a square. I want to make the coefficient of t square as 1. So that means I take this a square common and take out of this integration sign. So, what we will have? You will have dt upon integration of dt upon 1 upon a square, and this is t square plus b by a the whole square. So, now here it is in which form? Exactly in the form, this form number 3, that is dx upon x square plus a square, that is 1 by a tan inverse of x plus c. Now, we can write the integration of this one as 1 by a square as it is, okay. Then 1 by a is what? A means here b by a. So, 1 by b by a, and that is tan inverse x by a. X means what? Here is x is your t, by a means b by a, and that is plus c. So, after calculating this one, you will have 1 by a square here, and this a will be in the numerator, that means this is a by b, and tan inverse this a will be again in the numerator, a t upon b and plus c. So, this is equal to a cancel. So, you will have 1 by a b tan inverse of a t, a by b of t, t plus c. Now, you can replace this t, by your substituting quantity, that is t equal to tan x. So, that is equal to 1 by a b tan inverse of a by b, and the t is tan x and tan x plus c. That is the answer, or that you can say I, or answer of this question. So, again we have applied this third form. First, we have to bring the given question in the one of this form, out of these 6 forms, then we can write the answer or write the integration directly. Okay. Dear students, likewise you can follow all the questions of your exercise 7.4 NCERT books, but there are some more questions, some more types. Let me explain one by one. By using these 6 forms, we can solve some 4 more types of problems. Suppose your problem is given in this form, that is dx upon a x square bx plus c. That means in the numerator you have nothing but, that means you can have some constant also, or even a single one only, and in the denominator you have a quadratic expression. So, what to do in this form? We have to bring this form also in one among this form. That means first of all you have to take common out, you have to make this coefficient of x square as 1. So, how to take it? You just take a common out, that means 1 by a will be here, and integration and dx upon, that is x square b by a x, that is c by a. Now, here the coefficient of x square is unity. Now, what will be the next step? You have to make this one as a perfect square. Okay, in the perfect square, what to do? Perfect square x square plus this one a plus b whole square form, or a minus b whole square form, that is depend upon the question. Plus means a plus b whole square form, and minus means a minus b whole square form. That I will show in some examples. Now, here first of all you have to make it some perfect square, and then after we substitute. Same thing we follow, same thing in case of if the question will be given in this form also, that is dx upon under root of a x square bx and plus c. The same procedure, same thing only followed. Here again we have to make the coefficient of x square as 1, and then after make it a perfect square, and then after making perfect square, this part denominator part will become 1 among these forms. Okay. Let us give you one example. Let us take one example as example 1. I am taking I equal to integration of dx upon 2x square plus 3x plus 5. Suppose you are given the integration in this form. So, as usual, as I told you, first of you make the coefficient of x square as 1. So, you take these 2 common out, that means I had taken 2 common out, that means that will be also taken out of this integration sign, and this is dx upon x square plus 3 by 2x and then 5 by 2. This is after taking the 2 common from this part. So, what to do here? I make it as a perfect square now, and this is equals to 1 by 2 integration upon dx, x will be taken as x, and here what to do? Here I simply take the half of this one, that means it will be plus 3 by 4, the whole square I will take. X plus 3 by 4 the whole square will give you x square plus 3 by 2 x plus 9 by 16, one extra term will be there in this x plus 3 by 4 whole square, and that to be subtracted, that is why I put here minus 9 by 16 also, and we have 5 by 2 with it, 5 by 2. Now, we have to make a little calculation over here, and then so this is equal to 1 by 2 integration of dx upon, that is x plus 3 by 4 the whole square, and what to do here we get, that is 16, and 16 that is minus of 9, and then here it is plus, that is 68 40. So, that is equal to 1 by 2 integration dx upon, that is x plus 3 by 4, and here what you will get? You will get 40, that minus 9, that is 31, 31 plus 31 upon 16. Here is one square also. So, that is equal to 1 by 2 integration of dx upon x plus 3 by 4 the whole square, and I can write this 31 by 16 as root 31 by 4 the whole square, isn't it? Now, we have the integration, this part as, we have the integration as I equal to, you can say your I is now in this form, that what we have 1 upon 2 integration of dx upon, that is x plus 3 by 4 the whole square plus root under 31 by 4 the whole square. Now, what to do here? Again we use the substitution method. We put this part x plus 3 by 4 as t. So, suppose you are putting this part, suppose you are putting t, let t is equals to x plus 3 by 4. So, your dt will be, that is only dx. So, therefore, your I is now what? I is integration 1 by 2 integration of dx is can be written as dt upon t square plus root under 31 upon 4 the whole square. Now, look here, it is in which form? Out of this 6. Out of this 6 form, this is in the form 3. Form 3 is what? That is dx upon x square plus a square, and that will 1 upon a tan inverse x by a. You have to remember all these 6 forms, then only you can do the integration over here. So, that means here we can write 1 by 2, 1 by a is 1 upon a means root under 31 by 4 I can write here also, that is tan inverse x by a, x means t, and your a means what? Your a means again that is root under 31 by 4, so I write 4 here, that is plus c. Now, that is 2 to 4 and 2, that will give you 2 upon root under 31 tan inverse, that is 4. T means what you have assumed? You have assumed as t as, that is x plus 3 by 4, x plus 3 by 4 by root under 31 and plus c. So, this way after you can do some calculation more over here and you get your simplified result. So, this way you can perform the integrations of these quadratic functions given in the denominator form. It may in the two form, that is it also can be given here, it is not, there is no root, but your problem may be given in root form also. Either form, in both the cases you have the same procedure only. First make the coefficient of x square as 1 and take the constant outside of the integration sign, then you take the perfect square. How to make the perfect square? Perfect square, first just x square, from x square you take x and then plus sign, if it is plus sign then put plus, or if it is minus sign then put minus, and then take the half the coefficient of x and take the full as whole square, and there will be one extra term, don't forget it. When a plus b whole square you are taking as a perfect square, that means there will be 3 terms, and that 3 terms means we are taking 2 terms only and 1 terms have to subtracted or have to be reduced. So, that will give you something out of these 6 forms. So, there are 2 forms of such type of problems. Suppose you are given integration of dx upon dx, that is px plus q upon a x square plus bx plus c dx, or I equal to integration of px plus q upon, that is a x square root under a x square plus bx and plus c. These 2 forms. Suppose you are given the problem or questions in these 2 forms, then what can we do? Then we have to follow a particular procedure and want to bring these 2 forms, either one of these forms. What to do? We have the linear by quadratic form. It may be also in the root. So, that means we have to assume this linear part as this px plus q as some constant and the derivative of this one. I want to make the derivative, this linear part, as some derivative of this one. Like px plus q, let we assume that px plus q is equals to a, some constant a, and this derivative of, we take this a x square plus bx plus c and then some constant b. I assume this way. So, that means I want to reduce this quadratic form to some linear one by taking the differentiation or taking the derivatives, okay, and I want to make the derivative of this one. As we know, if we have the numerator and denominator, numerator is the derivative of this denominator, then we have the integrating procedure, or you have the integrating formula. So, that is we are trying here. Okay. So, we take this part px plus q equal to a times of derivative a x square plus bx plus c and some b. Now, what to do? Here I write a and derivative of this part will be 2ax plus b, this constant is 0, and plus b. Now, I compare the coefficient of x and the constant terms. So, coefficient of x, from the left hand side you have p only, and from the right hand side 2a and a. So, that means a will be, we calculate a from here, that is p upon 2 by a, that is your a, value of a. Similarly, here now I compare the coefficients of constant terms. So, that means constant term will be here q, and that is equals to a plus b. I can substitute this a from here. So, that means this will give you b times of p by 2a plus b, and from here we can calculate b also, and that b is equals to, that means your b will be q minus of pb upon some 2a. Here we calculate that b, and that a and b I substitute in this form. So, that means this px will be replaced by this one. Suppose I am getting some here a and some b, some constant. Now, I can replace this px plus q by using this one, this part. By using this part, I will replace this px plus q, because px plus q is this one. So, we will have, first part will be the derivative of this one, and second part will be some constant. Then after what I do, then after we have the denominator as same thing only. We make two separate integrals. We make two separate integrals. The first one will be in the numerator will be we will have the derivative of the denominator. So, that means that will be differentiable very easily. And second part, in the numerator you will have some constant b only. So, that b can be taken out, and we will have the denominator, and denominator that we can make a perfect square as we have done in the earlier question. Dear students, let us check on problem. Now, look at this problem. This problem we have the linear upon the quadratic within the root. Okay. So, what to do? Let us assume this 2x plus 3 as, let 2x plus 3 as some a derivative of this part, that means this will give us 3x square minus 4x plus 5 and some b. So, this implies a. Now, I take the derivative of this derivative is 6x and this is minus 4 plus b. Now, comparing the coefficient of x from both sides, that means here you have 2 and here you have some 6a. This implies your a is what? A is 2 by 6, that means 1 by 3, that is your a. Similarly, we compare the coefficient of constant now. Here we have 3, this implies that is 3 equals to, here we have minus of 4a and plus b. I can replace this a by this 1 by 3, that means minus 4 of 1 by 3 and plus b. That means this b is what? That is 3 is equals to minus 4 by 3 plus b, and this b is what? B is nothing, 3 plus 4 by 3, that is 9 plus 4, that is 9 plus 4, 13 by 3, that means our b is what? 13 by 3, that is b. Now, I put this constant a and b here in this part, that is a and b. So, that means 2x plus 3 also can be written as 2x plus 3 also can be written as also can be written as 1 by 3 times of 6x minus 4 plus b is what? B is 13 by 3. That means I can change my integrals by using this one now. So, now let us check. That is I equals to integral of 2x plus 3. Now, 2x plus 3 we can write at 1 by 3 6x minus 4 plus 13 by 3 upon, that is root under 3x square minus 4x plus 5 and dx. So, now I make two separate integrals. First one, I take this 1 by 3 out, integration of 6x minus 4 by root under 3x square minus 4x plus 5, this is one integral. Other will be 13 by 3 integral dx upon root under 3x square minus 4x plus 5. Now, I write this is as I1. So, our I equal to what? Our I equal to I1 1 by 3 times of I1 and plus 13 by 3 times of I2. So, your I1 is this one and your I2 is this one. So, I1, now look here, if you assume this is as t and that will be the derivative of t will be this one, that in this form we have adjusted this one. So, directly or by substituting you can write the answer of this one. So, that means I show you here, that means if you put t equal to something 3x square minus 4x plus 5, then your dt will be 6x minus 4 and that is the numerator. So, that means if you replace, your I1 will be 1 by 3 upon dt upon root t only, and we know that integration of root t is what? Integration of root t is 1 by 3, that is 2 times of root t plus c over. That is very simply you can finish it, even no need to follow the full steps. Now, look at this part, that is dx upon this one. This is exactly similar to the previous one, and the previous one now we have to take these 3 out and then after we make the perfect square and fit in one of this form. So, this way we can solve this type of problem. So, dear students, go through the exercise of 7.4 of your NCERT. With this we have completed the integration with a special formula. After this we next proceed to the next part, that is partial fraction, integration by partial fraction. Practice well and clear your doubts. Thank you and have a nice day.